All right, so today we are doing 6-4 notes for standard form. Standard form, if you looked it up online, would look like the following. Capital letters and lowercase letters are important. We have capital A, lowercase x, plus capital B, lowercase y, equals capital C. Okay, because we're an IB school, we do it in IB way. So IB standard form is capital A, lowercase x, plus capital B, lowercase y, plus capital C equals 0. So the only difference between a normal standard form and IB standard form is that it is equal to 0 and that C is on the side with everything else. So let's talk about what those letters all mean. So A, B, and C are all numbers. Okay, A, B, and C will all be numbers. X and Y are variables. A, B, and C will be numbers, whereas X and Y will stay variables. Okay, now there are some rules to follow for A, B, and C. So A, B, and C must follow these rules. And there's only 2 rules. Rule number 1 is that A must be a whole number. A must be a whole number. Number 2, B and C must be integers. A must be a whole number, whereas B and C must be integers. What do those definitions stand for? Whole and integers. What does that mean that my numbers are going to look like? Okay, so they said about whole numbers would be 0 through all numbers above 0, right? And integers are negatives, okay? What does that not include, though? Can I have half as an integer or a whole number? No, so whole and integer numbers don't have what? They don't have decimals or fractions, okay? What's the difference between a whole number and an integer? Say it again. Whole numbers cannot be negative. Okay, correct. Whole numbers cannot be negative. So, in other words, A has to be positive, whereas B and C could be negative. Okay, cool. Okay, so those are the two rules that we need to follow with standard form, other than the rule that it needs to look like standard form. Okay, so it needs to look like ax plus by plus c equals 0. Okay, now to keep in mind, every time that we talk about standard form in this class, I'm always going to be referring to IB standard form. I might not say IB standard form every time, but I want you to only do IB standard form. Okay, so this I wrote just for your knowledge. This is what is the expectation. Okay. So for the next handful of problems, what we're going to be doing is I'm going to give you an equation, or we're going to work through an equation, and we're going to figure out what is the issue. What is making it not follow the rules of the IB standard form? Does that make sense? So instructions are to convert the given equations into IB standard form. And a reminder, I'll be working with 3 different colors, so if you want to make yours color-coded, you can. Okay. So the first equation we were provided is negative 3x plus 2y minus 6 equals 0. Negative 3x plus 2y minus 6 equals 0. Question or an answer? Okay. So what I want for you to do is I want for us to figure out what is going to be the issue that's happening and how we're going to fix it. Okay, which is what you'll be doing on your homework. So what I'm going to do with my first color is I'm going to list what is the problem. What is causing an issue for this to be an IB standard form by the rules above. Okay, William. Correct. 3 is negative, so therefore the issue is that A is negative. Okay. Now in a different color, I'm going to list out how we can fix that problem. How can we fix that problem? Okay, if something is negative, and I don't want it to be negative, okay, but I want it to stay on the side that it's on, what could I do to... Good, so you could multiply, what else could I do? Multiply or divide by -1. Okay. If you multiply by -1 or divide by -1, it'll do the same thing. Some people just have a preference. So my problem was that A is negative. My way to fix it is to multiply by -1 or divide by -1. So if you do something to one side, you have to do it to the other side. You can't just do it to the only thing. So if you multiply to one side, you must multiply to the other side. Now, to clarify, when you do this and you're showing your work, make sure that you are writing 2 separate sets of parentheses to show that you are multiplying or distributing a -1. Okay. You cannot put parentheses around the entire equation because you can't put parentheses around the equal sign. You say the left side and the right side. And then you actually do the math of multiplying by -1. Okay. So negative 3x times -1 is positive 3x. -1 times 2y is negative 2y. -1 times -6 is positive 6. And 0 times anything is 0. So once you have fixed the problem, you want to make sure you've followed all 3 things. Is it in the correct order? Is A positive? And are there any fractions or decimals? Yes. Correct. Integers can be positive or negative. A is the only thing that has to be positive. Great question. So therefore, that would be my answer. Okay. So this is my final answer, which would be the IB standard form for my answer. Make sense? So we write down what the problem is, how we're going to fix it, do the math to fix it to get our final answer. Okay. I'm not going to write down problem fix every single time. On your homework, it says problem fix every single time, like a fill in the blank type thing. I'm just going to go back and forth with my colors. Okay. So number 2, 1/2 x plus 4y minus 3 equals 0. 1/2 x plus 4y minus 3 equals 0. So thinking about our 3 things that it must be true for it to be IB standard form. What is the issue for this one? A is not a whole number, so therefore we have a fraction that is causing an issue. Okay, A is not a whole number, or you could say that we have a fraction. Okay, to be even more specific, sorry, not to be more specific, to be more general, we have a fraction, right? Fraction is an issue regardless where it is, right? Okay, how can we change the number of 1/2 so that it is no longer a fraction? So I don't want to multiply by the reciprocal. I don't want to divide by the reciprocal. I just want to multiply by the denominator. So in this case, the reciprocal of 1/2 is 2, but in all cases, you don't want to multiply by the reciprocal, just the denominator itself. Okay, but that was a great guess. Okay. All right, so we are going to multiply by the denominator. So it means for this one, I'm going to multiply both sides by 2. Okay, and remember, you do need to write down what you were doing mathematically to do that. So that's why we have the parentheses and putting multiplied by 2. Okay, and if you want to use a dot versus an X for multiplication, that is fine. So 2 times 1/2 x gives us just 1x. Do I write 1x? Just x, good. And then plus 8y minus 6 equals 0. So as we go through these, we have we're doing 4 more of these for this type of problem. Okay. The reason why I'm keeping our problems general is because that problem could come up again. Okay. So rather than saying multiply by 2, I said multiply by the denominator so that if in the future you see a fraction, you're not like, oh, I have to multiply by 2. That's not the solution. If we have a fraction, you multiply by the denominator. Does that make sense? Why I'm keeping them general? Okay. So keep in mind, again, we're doing problem and fixing down on the right side. All right, number 3. 1/3 x minus 2 minus 1/2 y equals 0. 1/3 x minus 2 minus 1/2 y equals 0. Okay, right away, what issue is kind of directly happening? So we're not missing a Y. It's there. What's the issue? So they're not in order, right? It's out of order. Okay. So the issue is that it's out of order to begin with. Right. And so if something's out of order, we just simply rearrange it. Okay. Now, when I rearrange, am I going to have to like add or subtract anything to rearrange? No, if everything's on the same side, I just going to kind of move them how I want, right? So therefore, I'm going to change it to rewrite it as 1/3 x minus 1/2 y minus 2 equals 0. So at least we're in the proper order now. Okay, at least we're in the proper order. Now, what would be considered my problem? The fractions, and we got multiple fractions, right? Okay, so when we have just one fraction, we can just simply say multiply by the multiply by the denominator. But we have two different denominators. How would that change? We have more than one fraction, and I can't just simply say multiply by the denominator because I have two different denominators. Not the greatest common factor, the least common multiple. Good job. Multiply the LCM of the denominator. Okay, so reminding you, least common multiple means the smallest number that both of those numbers can multiply to. Least common multiple. Okay, 9 out of 10 times, it's just going to be whatever those two denominators are multiplied together. Okay, 9 out of 10 times, it'll just be whatever the two denominators are multiplied together. So that means my LCM is going to be 6. Okay, multiply both sides by 6. All right, what do we get for our answer? On that is correct. 2x minus 3y minus 12 equals 0. Yep. Yeah. Only A has to be positive. B and C can be negative. Only A has to be positive. So B and C can be positive or negative. A has to be positive. Okay, great question. Okay, obviously I'm at the bottom of my page. Give you a second to finish up anything there. Try the next one. Okay, number 4. Y equals negative 2/3 x plus 2/5. y equals negative 2/3 x plus 2/5. What is our initial issue that we need to address? It's out of order, but more specifically, what order is this in? It's in slope-intercept form. And in general, how could I get this out of slope-intercept form and into a standard form? What would be my solution, bless you, to fix the slope-intercept form? Subtract y. Now, when I subtract y, can I also rearrange the y to where I want it to be on the right side? Yeah, do I have to put it at the front, back? No, I can put it where I need it to be, which is in the middle. So 0 equals negative 2/3 x minus y plus 2/5. Now, does it matter that 0 equals on the left side? No, it doesn't really matter, okay? If it stresses you out at the end, you can change it, but it's really not a concern. All right, what is my next issue I should address? We got fractions, we got more than one of them. And what is my solution for when I have more than one fraction? Multiply by the LCM, good. And what would be the denominator LCM for this problem? 15, good. We're gonna multiply both sides by 15. Okay, because we have a denominator of 3 and a denominator of 5. 3 times 5 is 15. So we want to multiply both sides by 15. Question. All right, what should I get when I multiply by 15? So start off, hold on, 0 equals. Minus 15y plus 6. Remember, you gotta multiply by each part. Okay, and what's my last issue? I got 2 negatives. What's the issue? A is negative. And to fix that A is negative, we can multiply or divide by -1. What do we get as a result for multiplying by -1? That is correct. 0 equals 10x plus 15y minus 6. I'm gonna write number 5 and have you try it on your own now that we've done a few together. So number 5 is y equals negative 2/7 x minus 3/4. Y equals negative 2/7 x minus 3/4. All right, so hopefully you notice that this one looks very similar to the one above it. So therefore, the first issue is that it's in slope-intercept form. Which means the first thing you need to do is subtract y. Okay, so that should be your first step. Rearranging or subtracting y or putting it in order should be your first step. From there, hopefully you noticed that we had some fractions, multiple fractions to be specific. Okay, so we needed to multiply by the denominator LCM. What is the denominator LCM? 28. For this problem, it is 28. So I'm going to show that I'm multiplying it to the left side and to the right side, like I stated earlier, showing both sides because they're separate parts. We get 0 equals, what do I get on the right side? Minus 21. Okay, so 28 divided by 4 is 7. 7 times 3 is 21. And it was negative. Okay. And then the last issue is that A is negative. So therefore we can multiply or divide by -1. So my final answer should be 8x plus 28y plus 21. Okay, show of hands who were able to get that. Okay. Okay, we're gonna do one more of this type of problem. Number 6, y plus 3 equals negative 2/3 times the quantity x plus 9. All right, we have not seen it look like this yet, but what is it currently in? Yes, it's in point slope form. And when we have something in point slope form, what's the first thing we have to do to get it towards what I want? Yep. Distribute. Okay, now we also have to do something else. We distribute and, but I'm gonna fill that in a second. So first thing, let's distribute. So we're gonna have to distribute and something else, but for right now, I'm just putting distribute. And let's go ahead and distribute that number. Okay, what is negative 2/3 of positive 9? -6. Good. Okay, so we distributed, but we're not in IB standard form yet. What would I have to do next to get there? So I could simplify it into slope intercept form. Just speak specific to the problem, what would I have to do? Subtract 3, okay. and then we subtract y. So technically we did 2 steps. How can I summarize those 2 steps? So I subtracted 3 and I subtracted y. What was my ultimate goal in doing that? No. I subtracted 3 and I subtracted y. What was the ultimate goal that I wanted to end with? I wanted to make one side equal to 0. So your goal when you have point slope form is to distribute and solve for 0. Good job. Because solve for 0 could mean different things for different problems. Okay, you could have added something, subtracted something, whatever. But the ultimate goal would be to then solve for 0. We haven't finished yet. I was just saying, if you have something in point slope form, it's a 2-step process. You need to distribute and solve for 0. Okay, there is still issues. Go ahead and fix it to finalize it. There's still issues, so fix it to finalize it. Okay, so hopefully you noticed that there was a fraction. And typically when we have a fraction, a single fraction, we just multiply by the denominator. And hopefully you also notice that a was negative, which means we typically multiply and divide by -1. Okay, I had a question. Can I combine those 2 steps when multiplying? Okay, if you look at problems 4 and 5, we multiplied by a number, then we multiplied by -1. Well, what happens if I just multiply by the negative version of the original number? Can I do that? Sure can. Okay. So what could I do in 1 step to solve this problem? What could I multiply by? Multiply by -3. So if you notice that you have a is negative and you have fractions, you can multiply by a negative denominator or negative LCM. If that confuses you, keep it as 2 steps. If it doesn't, you are welcome to do the math at one time. You still need to write the problem and solution separately, but if that doesn't confuse you, if you have a negative a and you have fractions, you can do that in 1 step. So your final answer would be 0 equals 2x plus 3y plus 27. How many people were able to get that final answer regardless if you did it in 1 or 2 steps? Good. Okay, does that make sense to everyone that you can multiply by a negative LCM or a negative denominator? Okay. All right, that is the last of those types of problems. We're obviously going to try a different thing. Now that we've done all this work to figure out how to put something into IB form, we're now going to take it from IB form and put it into slope-intercept form, okay? So now that we've practiced all the ways of how to getting it into slope-intercept form, or sorry, into IB standard form, now we're going to put it into slope-intercept form. So instructions are to convert the given equation into slope-intercept form. Okay. And just a reminder, what is slope-intercept form? All right, so for the following problems, you do not have to do what we did on the original problems, which was writing the problem and how to fix it. Because these are going to be a little bit more standardized of how you fix it. So essentially you'll be simplifying it similar each time. It wouldn't have different problems in different ways. Okay, so number 7 is 2x minus 3y minus 12 equals 0. Okay, our goal is to get it to look like y equals mx plus b. What would be my first step towards getting it there? Yes. Good. Add the 3y to the right side. So I get 2x minus 12 equals 3y. Okay, so now we have the y on its own side. However, it's not completely isolated. So the last thing I would need to do is divide by 3. And remember, when we divide, we would have to divide by each term, which gives me 2/3 x minus 12 divided by 3 is 4, which equals y. Okay. Now, for this one, it just seems a little bit weirder for y to be on the right side. So rewriting it real quick to put it on the left side so that it actually looks like y equals mx plus b. Final out our answer. Okay, number 8, x plus 8y minus 6 equals 0. Okay, because it's always going to be currently in IB standard form, will my first step always be the same? Yes, my numbers, however, change. So my first step will be to, now to clarify, technically we would say move the y or move it to the other side, but it could be subtracting it or it could be adding it. Okay, so last time we added it, this time we would have to subtract it. And once we get y by itself on its own side, we then would divide by whatever the coefficient is, which in this case is -8. Okay. Go ahead and write down what the simplified version of that should be, because we should always simplify our fractions. Check with Seminary what you got. All right, so when we have x by itself, technically it's 1x, so this would simplify as -1/8 x. -6 divided by -8 would become +3/4, which equals y. So final answer, y equals -1/8 x plus 3/4. So in slope-intercept form, I want to see the m value. So it's important that I see that it's -1/8 versus writing the x on top. All right, let's do one more of those just to finalize that you have that skill set in stone. 3x minus 2y plus 6 equals 0. 3x minus 2y plus 6 equals 0. Right, you should get a finalized answer of y equals 3/2 x plus 3 to finish it up. Okay, any questions or concerns for that skill for converting IB standard into slope-intercept form? Okay. All right, the last problem we're gonna do is working with finding our x and y intercepts. So the instructions are to find the x and y intercept. And you need to show work solving for each intercept separately. So we're going to find the x and y intercept, and specifically you need to show the work for solving each intercept separately. Okay, which obviously we will go through right now. Okay. The problem is 3x plus 4y minus 24 equals 0. The problem we're going to work with is 3x plus 4y minus 24 equals 0. And again, the goal of this problem is we're going to find the x-intercept and the y-intercept. Can someone remind us what is a y-intercept? Yes. It's a line, it's a point in where the line crosses the graph at the y-axis. So the x-intercept would be the point where the line crosses the x-axis. Okay, so we're going to find both of those. So like we had talked about with x and y intercepts, they are where they hit the axis on the x-intercept on the x-axis or the y-axis. So let's first find the y-intercept because that is the one we're more familiar with. Okay, what does a y-intercept always look like? We have 0 first, and then we have a number, right? Typically we would write b because we're referring to slope-intercept form, but in reality it's some y value, okay? So what we know is that x always has to be 0. In order for it to be a y-intercept, x has to be 0. So to find our x and y intercepts in standard form, we're going to follow 3 steps. Okay. So step number 1, specific to y-intercept, is we are going to substitute 0 for x. Since we know x has to be 0, and I'm going to substitute 0 for x. Which would look like 3 times 0 plus 4y minus 24 equals 0. Now, once I substitute 0, what's the only thing I could solve for? I would solve for y. Okay, because we know x is 0, we want to figure out what is the y value. So 3 times 0 is 0. And we're left with 4y minus 24, sorry. 24 equals 0. So to solve for y, I would then, I wouldn't necessarily suggest moving the y. I'm gonna go ahead and add 24. Y can just stay there. And then we divide by 4. So 24 divided by 4 is 6. So the last step, I said it was a 3-step process. Step 3 is to write the answer as an ordered pair. So what is my y-intercept as an ordered pair? 0, 6. So my y-intercept as an answer of a ordered pair is 0, 6. So that is the 3 steps for finding the y-intercept. Now we're going to do similar but different to find the x-intercept. Okay, now we haven't worked with x-intercepts, but using your critical thinking skills, okay, what do you think an x-intercept would look like based on what a y-intercept looks like? Good. X is 0, so therefore we know that y would have to equal 0 always. We know that y would have to be 0 in order for the x-intercept to be true, or to have an x-intercept, I should say. And so my steps are going to be similar, but opposite, right? I'm not going to substitute 0 for x. I'm going to now substitute 0 for y. So that gives me 3x plus 4 times 0 minus 24, which equals 0. And based on what we've written there, and based on what we did above, that means step 2, we're going to solve for x. So when I look at this, 4 times 0 is going to be 0. I'm left with 3x minus 24 equals 0. First step should be to add 24. And then we need to divide by 3. So x equals x equals 8. Bless you. Okay. And last but not least, step 3 is to write the answer as an ordered pair. I will tell you once I get there. So my answer as an ordered pair would look like 8, 0. Okay. Every time I teach this concept, I will always have someone tell me the answer is 8, 6. Okay. 2 separate ordered pairs. Okay. Do not combine them. If you need to write that note to yourself, feel free to. Every year I always have someone tell me that the answer is the combination of the 2 numbers. Keep in mind it's 2 separate points. Okay. So 0, 6 is my first answer and 8, 0 is my second answer. There'll be 2 answers because you're finding x-intercept and y-intercept. Okay, it doesn't matter what order. I only went with y-intercept first because that's what we're more familiar with. You want to find x-intercept first, does not matter. All right, once you have done this algebraic work, which obviously you don't need to write the steps down when you do it on your homework or review or test, the last thing is to plot the x and y intercepts. Last step is to plot the x and y intercepts. So I'm gonna plot the x and y intercepts over on my graph paper. Go ahead and get out your rulers. All right, so on our graph paper, we are simply going to plot the y-intercept and the x-intercept as two separate points. So go ahead and do that. We have our y-intercept on the y-axis. We have our x-intercept on the x-axis. If you plot a point and it's not on the axis, something's wrong. So we have those 2 points by themselves. 0, 6 and 8, 0. Okay. And for this type of problem and this type of problem only, you would just connect those 2 points for your final answer. Nope, your answer would be the connection between those 2 points. So for this type of problem and this type of problem only, you only have to have 2 points and you connect them. You don't need to find slope or anything like that. You just find your x-intercept and your y-intercept and connect them like we did just here. Okay, that is the end of the notes.